Hello student, the question says the current density in a solid cylindrical wire of radius r as a function of radial distance small r is given by J as a function of r is equals to J naught into 1 minus r by r. The total current in the radial region from r equals to 0 to r equals to r by 4 is. So basically, we have a cylindrical wire. Imagine I am zooming this cylindrical wire in an electron microscope, okay? Or else, how does a wire typically looks like? Wire typically looks like this to us. Understood? You can't see the thickness. Imagine you are looking at this through a some microscope or something like that. Then, if this is the axis of this, he is saying the J value, current density, is radially changing. You can clearly see at R equal to R, the current density is 0. That means most of the current is flowing near the axis. That means most amount of the current is flowing near the axis. As you are slowly going away from the axis, the current density is decreasing and it is almost becoming 0 also, the amount of current that is flowing through this. So most of the current is flowing near the center. He's asking us to find the total current in the region from R equals to 0 to R equals to R by 4. From R equals to 0 from the axis to a distance of R equals to R by 4. To solve this problem, since the current density is changing, it's a variable, we will use the concept of integration. What we will do is, at a distance of R, I will select a small strip, small imaginary cylinder of thickness dr. So its thickness is dr. So at a distance r, I selected a small strip of thickness dr. This is exactly how it looks like. So at a distance r, there is a small thickness dr. And let us assume the current flowing through this. What will be the area of cross section of this thickness that we have selected? If you want area of cross section, dA would be equals to simply 2 pi r is the circumference of this circle into its thickness, dr. Now, if I want current flowing through this, the current flowing through this is dI equals to J current density into cross-sectional area, the selected small cylinder cross-section area. Once we understood this, if you want the total current, let us integrate the left side and right side. So if you integrate the left side, integral dI equals to integral J into dA. So the total current, let me call it as I, is integral J dA. The expression for J is given in the question as J naught 1 minus R by R. So let us use this. So J naught 1 minus R by R into dA is 2 pi R into dr. Once we know that this is 2 pi R into dr, let us try to solve this problem now. I equals to J naught would be outside, 2 pi also would be outside. So I can write integral of R dr like R minus R square by capital R into dr. Let me take it to the next page. So we basically get J naught into 2 pi. I will break it down into, I'm doing step by step so that you understand. Usually we should do it as quickly as possible in a single step. So J naught into 2 pi integral R dr would be R square by 2 minus 1 by R integral R square dr would become R cube by 3, because we know integral x power n dx would be x power n plus 1 by n plus 1. I have used that logic here. And what are the limits of this integration? The limits of integration is I want the value from 0 to R by 4. I think he's asking from x equals to 0 to R by 4. Yes, we want it from 0 to R by 4. So let us substitute it. And here I can write the current that will be flowing actually 0 to I. So the value of I would be equals to J naught 2 pi. Let us substitute these values here. So I will get R square divided by 16 twos are 32 minus 1 by 3r into r by 4 whole cube. So it will be r cube. 4 4s are 16. 16 4s are 64. So we can cancel this r and this r square. So finally we'll get I equals to j naught 2 pi r square. I think we can even bring 32 also outside. So I'll get 1 minus 1 by 32. If I remove it, 32 2s are 64, 3 2s are 6. So you'll get basically 5 by 6 j naught 2 pi r square divided by 32. So this is the final expression we got. Pi table, we can cancel it 3 times. So we get current is equals to 5 by 6 j naught 2 pi r square divided by 32. So 2 table 3 times. So I'll get 5 by 96 j naught into pi into r square. So this is the final value that we obtained in the given problem. Hope you understood how I have solved. Again, I will repeat what we have done. He has given the j is changing continuously with the distance, and he wants the current flowing from r equals to 0 to r equals to r by 4. We want the current between this region. Since we want the current between this region, so we have used the concept of integration. We have selected a small strip. We wrote the dA expression. We have substituted everything when it comes to integration. And finally, we got the expression for I. The final expression for I, we got it as 5 by 96 j naught into pi r square. You can clearly see how the current density is decreasing so rapidly, and we ultimately got current in that section is just 5 by 96 j naught into pi r square. Hope you understood how I was solved. Thank you.